Good morning to all. And today we are going to start with the new chapter. So this is the layout strategies. In this chapter, we are going to look at a different type of layouts. So the outline of this chapter. First, start with the global company profile. That's McDonald's layout. So, and in the past 5 decades, 50 years, McDonald's, this fast food restaurant, they changed their layout many times, and also in this chapter, we are going to look at why layout strategy is so important. Yeah, it's going to impact the operations efficiency. And then what types of layout we are going to look at. So, and we will look at the office layout and a retail layout and warehouse layout. And also some like fixed position layout and process-oriented layout and work cell layouts. And another one, it is repetitive and product-oriented layout. As you look at these topics and bullets, you see this layout is very closely related to the process strategies. In process strategies, we touch base with fixed position and process-related focused strategy, and also repetitive and product kind of like related process. And in this chapter, we are going to go a little bit detail, different process strategy related to different layouts. And here, this is the innovations at McDonald's, this fast food restaurant, and what happened in the past maybe more than 50 years. So in the 1950s, they changed their indoor seating. And then in the 1970s, they designed the drive-through windows. And then they changed their menu and breakfast menu. And then in the 1980s, they added some play areas. You still can see in some of the kind of like fast food restaurant, you can see the adding play area, but not in everyone. Certainly, it's very attractive to kids. Okay, and then they redesigned their kitchen layout. So now they add some kind of like recently they added their self-service kind of like parts, and then now there are 3 separate dining sections. And you will see, and this is what happened in the past 70 years, almost. So 6 out of the 7 are really layout design. Why they want to make the layout design? They want to make the information flow quickly, and the material flow quickly, and also people flow quickly. So when a person came to drive through, so they want to get their food and to go. So that's the idea. So and all of the layout change related to how to serve the customer in a quick way and how to make the operation in an efficient way. And this is the new layout. And there are 3 separate dining areas. They have the linger zone with nice chairs, comfortable chairs, and I think it's very convenient. This store has a Wi-Fi connection, so people can drink coffee, and especially for the senior people. And they can read their newspaper or bring their tablets with them and watch the news and then relax, right? And then the grab and go zone, they are kind of like a high counters, so people just wait a short time. Mainly, that's kind of like I would say is like my age. Sometimes I come over here and I need to grab some quick food for the kids. So, but this is the grab and go zone. And another one, it is a flexible zone for the kids and the families, so they can spend more time with the entire family in this area. And they change their layout or they design their layout is try to reflect what is the best competitive advantage. For like McDonald's, this company, this is a fast food company, is relatively cheap and compared with some other kind of like a restaurant chains, and they want to serve the people in a quicker way and make it fast and also taste and also fun. And that's why they have some kind of like kids play areas, and that's their like I would say it is the competitive advantage compared with other like fast food chains. Maybe Burger King also has like a play area, but because I didn't really go to that place very often, I do know McDonald's is very attractive to kids. I don't know. Maybe they have the same service because McDonald's, they have a kids meal, Happy Meal, they have small toys, and I believe like a Burger King also probably have the small kind of like souvenirs of like play toys to attractive. And am I right? Maybe yes. Okay. And some of them, not quite often you can see. Yeah, the learning objectives we study in this chapter, and we would like to complete the following like tasks. So discuss the important issues in office layout, and also the objectives of retail layout. Office layout and retail layout, they are two different kind of like ideas. So, and also we want to let you be familiar with the modern warehouse management system, some of the technologies used in the system, and how can help them to run the warehouse in a quicker way and also in a effective way. So, and then the next one, it is identify when fixed position layouts are appropriate. What is a fixed position? So it's something like a big project. You cannot change the location of the project that you are working on, like a house building and construction project, and also, and even not in construction field, some other field like in manufacturing, also you can see fixed position as well. So airplane manufacturing or fabrication and other examples. So we will see when you want to when the fixed position layouts are appropriate, and how to increase the efficiency of a fixed position project and layouts. And explain how to achieve a good process-oriented facility layout. And also we are going to define the work cell and the requirements of a work cell. What is a work cell? Work cells is you bring some equipment together, try to produce a unique product or a group of the similar products. They call them product family. So that's the cell, work cell. And then for the product-oriented layout, product-oriented layout mainly is assembly line. So, and explain how to balance the production flow in repetitive and product-oriented facilities. I think our in-class practice will mainly focus on this one, how to balance the product flow in a repetitive or product-oriented facilities. That's one of the kind of like practice we are going to do in this chapter. Another one, it is when you have the process layout. and a process oriented to the facility layout. And how do you organize this process? Will you jump from here to here, here, so, and randomly, or you just sequentially, or you organize your position of the process according to some certain rules. So there is the mathematical model in process oriented facility layout. We can apply this in our class as well. This is another in-class practice we are going to complete in this chapter. So, I designed 2 in-class work for this chapter, and today I'm not sure we can we can only be able to touch base or start the work the first in-class work. This is 13 location, and the in-class practice is 13. But I'm not exactly sure if we are going to finish in class 13 all the 3 kind of questions I put over there. We will see. Otherwise, we will continue next week. So, in the mathematical model, we only will be able to do 2 kind of in-class work in this class. And what is the importance of layout decisions? The objective of layout strategy is always try to develop the effective and efficient layout, so that will meet the competitive requirements. And what is your uniqueness? So we said in the beginning of the chapter, and the competitive advantage include 3 different competitive advantage. One, it is cost competitive. That means your price is low. And another one, it is uniqueness. It's a differentiator from other competitors. And the third one, it is a quick reaction. So that's the 3. And your design of the layout should be able to meet the firm's kind of a mission or a competitive requirements. So if your design, your company's competitive advantage is differentiation, you need to think about how this layout will help you to realize this goal. If the layout, if the company it is try to use the low cost, a low service price, low product cost or price to attract a customer, and then you need to think about how the layout is going to help me to reduce the operation cost, product cost, service cost. And if you think it's okay, differentiate or so make it unique. Maybe you can add some fancy part of the product, or to accordingly you can design your layout to be fancy, to be attractive. This is the idea. Why it is important? What is the objective of makes a different layout? And layout design considerations include, and of course we are going to try to make the high utilization of the space, whatever the space, the equipment, and also people. You don't want to idolize the equipment. And because even though idolizing the equipment, you still have to consider the depreciation fee, because you pay this equipment in the beginning with a chunk of money, And then we want to design a layout to facilitate the flow of information, the flow of materials, and even flow of people. And another consideration, it is employee morale. I don't know how you can, but I would think about when you design an office layout, you want to think about privacy as well. Some kind of privacy and some kind of morale kind of considerations. And for safe working condition, of course, nobody, and can ignore this part. Safety, it is the high priority in all of the organizations, no matter it is in like a service institution or manufacturing institution. If you got a lot of OSHA like accident report of the organization in 1 year, so I think the managers will be in trouble, and they may, the company may suffer some kind of like profit to pay their fine, to pay their whatever the like punishment or insurance. So that's why safety consideration, it is very important, and also improve the customer and the client interactions. And when you design the kind of like facility, for example, in retail design, so you want to make sure there is enough or like a customer and client interaction should be maintained over there, and some kind of like a service desk should be available, or counter should be available in the retail or departmental stores. And another one, it is flexibility. It is more and more important for flexibility. I mean, especially I think it is for some of the manufacturing companies, because the customers require like a variety of products, uniqueness of their own kind of like desirable product. So we may put the equipment on the wheel. So put the equipment on the wheel means it's very easy to organize your like work cell. So for one project, you need 2 lathes and 1 mill and 1 kind of like inspecting machines. So that's 4 equipment. Maybe another kind of like a project that you don't need 2 lathes. So you want to add a robot over there. Then you need to reorganize the equipment to be a different cell. So I don't think all the companies say, oh, because I see a new kind of like a layout, I need to buy new machines, completely new. No, if you can use the existing machine and organize their position and meet the requirement, that will be the best. This is what we see as the consideration of flexibility. So, and this is the flexibility in manufacturing. Use this as an example. So the types of layout in this class, and we are going to look at this type of layout. So office, retail, warehouse, and these are the 3 kind of like organizations we are going to look at. If you look at a fixed position, process-oriented layout, and work cell, and product-oriented, these are closely related to another chapter, and a process strategy. So process strategy, they are closely connecting with layout strategy. Different process may ask for different layouts. And for office layout, obviously, and is how to put the office workers in different spots, different locations. We see probably historically a big kind of like open area. All of the office workers work in the same area without the dividers. That's in the past. Probably in our textbook there is a picture over there. And then they add a small kind of like dividers and make like a cubic, so people can work in over there. And also, when they put the group of people, for example, we are all the design group. They want to put the design people in the group, and that group, it is like a kind of like a supply chain management. Or another group, it is quality engineers. They can organize the people in this in terms of functional department, or they can organize based on project. So each project asks for these, 2 design engineers, 1 supply chain, and 1 quality people. They may work as together. So this is, and position the people And also they need equipment. Office workers need like printing machines and also scanners. So space and office to provide for movement of information. So it's nice and easy to organize. The people work together. They have a conference together. But the people say, oh, now we use a lot of email. We use some kind of like a social media. They can work as a group. Yes, that can be done. But if you work in the the same kind of like facility, it's nice that you can have a face-to-face meeting, can solve the problem right away, can talk with each other, and this is the more direct kind of like interaction. And for retail layout, allocates display spaces and responds to customer behaviors. And warehouse layout, and mainly is try to balance the space requirement and material handling. And material handling, if you want to move any single part, single kind of like material or a big chunk of material, that means moving means cost. So this is definitely it is the cost. You want to reduce the moving transportation of materials as small as possible. And also how big of the space requirement. So this is a warehouse. The rest of them, fixed position is just the layout requirements of the large project, ships and buildings. And the process-oriented layout deal with low volume but high variety requirement. And in the old time, we see the job shop arrangement, a layout, so to meet the process-oriented layout. And then the next one, it is work cell layout, arrange machines and equipment to focus on production of a single product or group of the related products. They call them as like a product family. So they are all shafts. So they are all kind of like shafts. Shaft means, okay, it is the rod and needs to be produced from the lathe. So, but the rods have, some kind of like a different kind of like geometries, even though they are all kind of like a rod, but they can be called as a family with some kind of like a difference. And their similarities of the geometry ask them to be produced in the same machining process. Okay, so product-oriented layout is to try to find the best personnel and machine utilizations, and in the repetitive or continuous production. And here gives some examples of office layout and retail warehouse and project or fixed position layout. And job shop actually is the process-oriented layout. So the example it is could be the hospital, and because all the hospital it is a high variety but a low kind of a utilization of the equipment. Each patient needs a different treatment plan. So they need to go to different rooms for inspections or for like treatment. So it's a high variety. And some other work cell in the product family. So their layout, they give you like a Hallmark cars, wheeled coach, ambulance production. So the next one, it is repetitive and continuous production. So mainly it is for assembly lines. So, for the layout, I said in this class we only have two mathematical models. But you see we have how many layouts? We talk about 7. So 7 layout, that means you only have 2 mathematical models, to be honest with you. And if you read the book, they said the layout strategy, and it is most of the time it is the kind of something of art. What do you mean? Something of art. Art is mean, okay, there is no kind of like a rule to say, there no mathematical rule can quantify them to say this is the best and another one it is worst. So art means for some of the clothes I see this is ugly and other people think, oh, it is beautiful, right? And like my daughter, she always said, oh, you are so, why you wear this? I said, well, and this is traditional, it is ordinary, but for younger people, they want to have like something really modern, right? This is art means you cannot use a mathematical model to quantify everybody's idea together to give the best solution, to give the, to judge, okay, which one is best, which one it is worse. So in this case, a lot of the layouts, you cannot say them wrong or right. And but we have some kind of like a good considerations, at least this is the bottom line. You want to make sure your layout design will help you to handle material. You need some material handling equipment. Like in our production lab, we have the trolley, we have like a fork truck, we have smaller kind of like handling device. We have like a automobile handling device. So everybody will need to use this. When you design the good layout, you also need to consider about what is the capacity design. In the previous chapter, we talk about the capacity. Capacity means what is the maximum condition you can handle. And then according to the maximum condition, then you need to figure out what is the space you need to handle all of the like products. Then do we really consider environment and appearance, aesthetics? I think environment, yes, we should. And because in our office area, several people complain it's so cold. It's so cold. It is cold. And because the building, it is quite old, and the ventilation system somehow is not balanced. Some of the area is very hot. Some of the area it is cold during the winter time. It's not comfortable, and to be sit over there for all day. And for appearance, I think it is somehow attractive. Well, and when you look at some of the buildings, you see the building have like art designs, art displays on the wall. That's very attractive for the visitors, for the new coming students or the students they like to visit UNI to see whether they want to make their decisions to come to UNI or go to Iowa State or go to Iowa. And many of the visitors, they come over here, they said this locker is old. I don't know. I didn't come here for high school. They said this is the high school style of the locker, right? So, and it is important. And if you have the efficient enough kind of like resource, you want to do the decoration, yes, please do this. And also the good layout should maintain information flow. That's very important. And information flow is not only for important for office people, but also good for material handling, warehouse, and even retail design as well. The cost of moving between various work areas, and we try to reduce the transportation as much as possible because this is the non-value added process. So if you can reduce, obviously you can reduce, make the operation to be lean and effective. And for office layout, we already said we want to make them feel comfortable, feel like safe, and try to make the information flow to be effective, direct. And so here is that movement of information, it is the main kind of like a distinction for office layout. That means it's more important and for office design, office layout design. And so there is a chart to, and relationship chart gives the example, how do you assign people in different office areas. This is called a relation chart. The relation chart code as A means absolutely necessary. And E, it is means especially important. And I means yes, it is important. O means it's okay. It's if you know, and then U means unimportant. X is not considerable. When you try to organize the people together, like a department together. This is office design. They include accounting, include marketing, and include operations, graphic art designs, and information technology, IT people, and social media relations, and even the launch area. So they found the important thing is the operation. They should have a close relationship or working connection with marketing people. So if you use this and draw this line and use the horizontal line operation, and then you want them kind of like cross together. So cross them together, you find out this is A. A means absolutely necessary. So here we draw the marketing over here, and then follow and draw this line for operations, and then they have the interaction. So that means operations, they will have absolutely kind of like a connection. They want to sit together. Similarly, if you look at accounting, yes, accounting and operation, they have this A as well. A is absolutely necessary. They want to get closer. And for art and graphical art, and look at over here with operation, it is it's okay. It's the relationship is not as close as the previous examples, like the relationship between operation and marketing, operation and accounting. So this chart for information technology, so absolutely it is a connection with graphic arts, because some of the website design or some kind of like information related to, they need to make this beautiful like art design. They want to talk with each other more frequently. And this relationship chart can give you a kind of like a big picture how the departments of the different offices, they can connect with each other. They want to talk with each other more often in some of the groups, and versus other groups, they, you know, not really important. For example, the accounting, and then this one, accounting. And the launch area, not, you know, they can be separate far away, that's fine. So E, it is especially important. They have the E. It is this is operation and with launch areas. So some kind of like ideas. This is a relationship chart can be used to plan your office layout, retail layout. Objective is to try to maximize the profitability per square foot of the floor space. And the sales and profitability would vary with the customer exposures. And some of the customer behavior, they want to go to the store, grab the things, go quickly. Some of them, they like to, I go to this area, I go to another area. They wouldn't mind spend more time in the store. So, but there is a kind of like a positive relationship. And the more exposure the product was exposed to customer, and the higher possibility they will buy it. So that's why they want to make sure and to try to, from the layout design, they want to attract the customers to go to different area. Even for the people like me, I don't want to spend much time in store. They want to attract me to this place, to that place. You have to go. If that's the way they can design, that means the more exposure given to the customer and possibly to get more kind of like a profit. Supermarket design is very interesting. I think it's very true. Okay, so try to locate the high draw items around the periphery of the store. So what are the high draw items? Like necessary items. What do you need for each week? You need to drink, right? You need bread. You need, so some kind of like, at least, people need a little bit of fruit and bread and milk and a cereal. So look at these items. They are placed in a different area. For the milk, it is always in the backside of the supermarket. And fruit is in the front. They try to guide you. After you grab the fruit, you want to get the milk, and then you have to go to the very back. But in between, you have to walk through some area. That's the exposure you are required to look and to see. So use prominent locations for high impulse and high margin items. Yes. Okay. High margin items, that means high profitability. So, and distribute power items to both sides of an aisle and disperse them to increase the view of other items. And try to use the end aisle locations. Yes, try to use the end means customer need to walk further, walk longer time. And count these emissions of the store through careful position of the lead-off department. So here it is an example of the supermarket layout. So this is dairy. And here where it is the bakery is over here. And produce a little bit here. So if they, this is the checkout area, and I didn't see where it is. So they want to grab these items. They need to probably walk a lot longer time in the supermarket. And I don't know why Walmart always put their clothes in the middle section of the kind of like space area. And according to this book, Walmart is trying to make the promotion of their clothes. So, and obviously, if you look at which store they put it in the very obvious position try to catch the customer's eye, that means they want to highly promote this product. And for service space, I wouldn't say more. I just make you feel it's pretty. That's all what I would like to say. Pretty, comfortable, and try to appreciate their layout. If you have extra money, of course, if you feel good about that, you can buy it. That's all. For warehouse and storage area, is to try to find the optimum, like a balance between handling cost and the cost associated with the warehouse space. So remember, in a warehouse, it's not just a flat area. You need to think about the vertical 3D space as well. Some of the warehouses, they have a very, very tall stacks by stacks. And then they need some material handling equipment, conveyors. They need like high trucks. And let me see my Google space, Google Drive is working. Google. I uploaded some. Yeah, here is this is the warehouse I visited during summer. It's quite busy, and this type of like truck is so I even feel not really safe, to be honest with you. I think all the trucks are, so here is showing the conveyors. So it's a big, tall, very tall building, and they use the conveyors to move the this is the operator trying to move the desired parts, put into different bins and put in the conveyor. And here it is the kind of like a shelf, or I do not know how to call this, but it is layer by layer. It will separate it for you. It's grabbing the object and put it into different bins. All the workers, in their wrist, they have kind of like a big watch. It's not a watch, but it is the material handling equipment. They can get the information read from their watch. Okay. And material handling equipment is very important. Here it is the conveyor, and it's very long. So for Amazon, they have robots. Here, in this company, I didn't see robots, but I do see a lot of trucks moving around and conveyors and over there. And also I asked them, I said, when I came to visit, I feel rush because everybody is moving quickly and all the materials is moving quickly and their truck is moving quickly. How do you make sure the safety? Yes, they do. They said, oh yeah, we have to make sure everybody, when they gave them the training in the beginning, and I think their monitor is very important. What I said, it is their information, like a management system, is very effective. They want to make sure the information flow correctly. And all the material handling costs include incoming transportation cost, storage cost. How do you find the desired parts and the material? That is the cost as well. So also include outgoing transportation and all the equipment, all the supervision, insurance, everything is included over here. So when you think about reduce the material handling equipment, material handling cost, so you need to think of all of them, which one you can reduce. So that's the minimize the damage and spoilage. In the I mean the package, sometimes the package, it is giving the sign, say this is the glasses containers, you want to be careful, and put it in the correct location. So this is important to try to minimize the damage and try to minimize the material handling cost. Here, what I'm seeing is that's the technology used in material handling in the warehouse and the storage. That's the automated storage and the retrieval system. Without this, I don't think the distribution center can work effectively. And here it is the design of one of the warehouse and the storage area. You see, this is the 3D area, not just the one floor, but also you see the stack storage over here. Dock location is the key component in this design. So where you put your dock and how do you receive the incoming material? How do you ship it out? What is the meaning of cross-docking? Cross-docking is saying, and it's better not make any storage in the distribution center at all. Ideally, if we can receive the incoming material directly sent it out, that means you have a very minimum storage time. So time means money. Time means everything. So this is the idea of completely eliminate the storage time and make it directly to the ship it out. So materials are moved directly from receiving to shipping, not placed in the storage at all. And in order to do this, I mean the schedule design must be accurate, and also the automated storage and retrieval system must be monitored, updated to date, and very quickly. So they want to use barcode, they want to use identification technology to make this happen. And cross-docking, it is a good strategy. It is the ideal situation. What do we mean random stocking? Random stocking is mean, okay, you can put it anywhere you want in the storage house. And as a manager or operationer, and they know no matter you put it anywhere, they can find the location of the desired parts right away. So, and this brings a challenge is, how can you do that? If you do not put this in an organized way, If you want to put anywhere you want, that means you have the technology to help you to locate the items. So that means they require the automatic identification and system. They need the information technology to help them to realize random stocking. And random stocking so allows more efficient use of the space, and you really don't need to reserve some space for certain parts. Whatever space you see, you can use it right away. So you can the key tasks in random stocking is maintaining list of the open locations and maintain the very accurate records, and also try to minimize the travel. And the information technology must be used over here. And when we talk about fixed position layout, and fixed position normally means is the product will be remain in the one place, from the beginning to the end. You do not change the location. And all the people work for this project, for this part, they have to come to this location to make this happen. And they need to send the materials to the location. And there are some kind of like a complicating factors, because the space is normally is a limited space. For the operating room, it is. And for some of the construction project, it is a limited space. And different materials are required at a different stage of the project. Sometimes in the beginning, you need only concrete material, and in the end, you need like painting material. You need appearance, some kind of like material. And the volume of the materials is they call it is dynamic. That means sometimes it's a high requirement, sometimes it's a low requirement. You need to make sure you have the good schedule to send the material at the good time or the desired time. And some of the house and residential house building, it is a fixed position project. And normally you do everything on site, but now they found a more effective way, and they try to pre-assemble some small items or systems together and ship it to the construction field. That means, okay, they have already done some sub-assembly work and reduce the kind of like the time spending in the fixed position. So this can be done to reduce the not changing the layout, but it's going to help reduce the total time. For process-oriented layout, like the machines and the equipment, sometimes we need to group them together. And flexible and capable of handling a wide variety of products or service. And the example is, some of the machining project. And this is all the kind of like milling area, mill. And this is all of the lathe area. When we say it is area, may not be just the one machine, could be like multiple machines over here. And here it is lathe. So process-oriented like a layout, sometimes the part go to lathe over here, and then jump to over here, and then go to the heat treatment to another kind of like functional area, and then go to the kind of like a machining or precision machining. So this is kind of like a process layout. The advantage of this layout, it is you can do as maximum variety of the products because all of the machines are general equipment. But the disadvantage is low utilization rate of the machines. That's a high idling. So low utilization. So it's very hard to improve the efficiency of the usage. So scheduling can be very difficult, and consider the setup time and the material handling time and the labor cost. This one, it is quite high if you do not design the good layout. So this is the process-oriented layout showing two different patients. They need to go through different process. It's similar to the machining like a process. And all the hospitals, they are designed for general, for everyone. So for specific people, A, broken leg, they go to the blue kind of like lines. For the patient B, it is a heart disease. So they need to go to the red kind of like layout. So it is the process layout, but here, for the process layout, we try to, one of the mathematical model we establish over here is try to reduce the transportation or reduce minimum the cost of walking time or material handling time. For the manufacturing, we say is try to minimize the material handling time. And for the other operation, it maybe is try to minimize the transportation. For example, there's few booths in the orientation event for a university for incoming students. One booth is for advising. Another booth is for insurance or health forms. Another form it is for advising and admission, so whatever. So if this is the case, you want to direct a group of the student to admission desk first, and then go to another, it is insurance and student health paperwork. Another one, it is go to general education, another one, it is called like a major or department advising. For these type of things, the layout goal is to try to reduce the space of this. How do you organize this different functional desks to reduce student walking time, transportation time, or this is called, for process-oriented layout, our goal is minimize the cost of material handling or minimize the cost of, or minimize the time of transportation or walking distance. The basic cost components are the number of loads or the number of people moving between the centers, moving between the different locations. And another one, it is the distance loads move between the centers and the locations. So one which is we call it is is the load. So how many parts you are going to move. Another one, it is the distance you have to move from one location to another location. This, we come up with a mathematical model, try to minimize the cost of this. Well, you have seen sigma I from 1 to n, j from 1 to n, but xij and cij means xij is number of loads. So loads means the number of parts move from one department to another department. And then the cost, it is means, okay, cost related to like a location, related to distance. So C means the cost to move a load from one department to another department. So in the process layout, oriented layout, you want to make sure to minimize the cost of the moving. So cost of the moving include two pieces of information. One, it is how many number of the loads you want to move. Another one, it is how much cost if you move one part. Okay, so here is the example. I think we do not have time to finish the in-class work. And this in-class work is arrange the 6 departments in a factory to minimize the material handling cost. Each department is 20 by 20 feet. And the building, it is 6 feet long and 40 feet wide. So, and it's something like this. So here it is 40, and this is 60. And you need to arrange the kind of like a 6 department, 1, 2, 3, and 4, 5, 6, and to minimize the material handling cost. There are 6 steps. So construct the from to matrix. I will explain what is the from and the to matrix. So the next one, it is determine the space requirement and determine an initial schematic diagram. How do you develop this initial schematic diagram? And then determine the cost of this layout. After you have the layout, and then try to improve the layout to calculate the cost to rearrange this layout. This is a from to matrix. Here they have 6 departments: assembly, printing, machine, and receiving, shipping, and testing. That's the 6. Here you have the same as the column. The from to ship to, it is so from assembly to printing. So this is from this 1 to 2 to 3 to 4 to 5 and to 6. This number of loads per week provide you the data, the parts you need to move from one department, from assembly department to printing department. Each week you need to move 50 items. And then from assembly to shop to machine shop, you 100. So there's no movement between 4 and 5. There's 20 units or 20 parts need to be moved between assembly and testing. So each one by one, we created this. This is called from and to matrix. So after the matrix, you determine the a space requirement. If this is the space requirement, you systematically put them as according to sequences. Say How about we put a 1, 2, 3, 4, 5, 6 over here. And after you put over here, so the next one is the schematic, okay, of the interdepartmental flow diagram. And according to the from to, then from assembly to painting, they are 50. From 1 to and to a machine shop, it is 100. And so this gives you all of the material flow you need to take care in 1 week. Now you see here, these are the high volume, correct? 100 is the high volume, 50 is the high volume, and 50 is the high volume. So according to this, you want to make sure I want to put them closer together as much as possible. And if you look at this kind of like 1 and 3, actually this is 100. It's not good if you put them far away. It's better you put them together. So this is some of the idea is how do you arrange the layout to minimum the material handling list. And there is a mathematical model, but in our textbook, we are going to learn it's not the mathematical model of using the software. It's instead we are going to use the trial and error method. So for trial and method, if I put the calculator according to 1 to according to 1, 2, 3, 4, 5, 6. So this is the cost model. And between 1 and 2 and 50, it is the total cost. Because when you move the one item from 1 to 2, because they are closer together, so it's going to cost $1. But if you move one item from 1 to 3, because they are far away, so it's going to cost $2. So that's why from 1 to 2 is 50 times 1. Here it is 100 times 2. That's the reason why you see 100. And from 1 and 6, it is 1 and 6 is far away, so it is $2 for each piece. That's why you see 40 is equals to 20 times 2. So this is the total like a cost, and for this type of like a layout. And then the next, we have the in-class practice. I showed you is an Excel file how to calculate the kind of like layout cost. And then the next one is rearrange it and put revise it. So after you revise, you put 1 and 3 and put a different layout, and then we can reduce the shaping testing process layout. Okay, we do not have time to be able to work on the Excel file, to be able to calculate and then just stop over here, and the next time we will continue, okay? There's no in-class work submission today. So, but next time we are going to start with in-class work right away, okay?